What if I told you that one of the absolute best lessons in science communication is hiding in a simple party trick, one that just involves some fruit and a fizzy drink? Today, we're going to break down the viral dancing raisins experiment. We're not just looking at the science, we're digging into what makes it such a brilliant piece of teaching.
So can you do it? Can you really make raisins dance with stuff you already have at home? The answer is a huge, resounding yes. But that's not the real question. The real question is, how does it work? And maybe even more important, how does a super simple experiment like this become such a powerful tool for explaining some pretty complex ideas to, well, anyone? That's what we're going to figure out.
All right, so our source material for this whole thing is a script from a kids show, and it frames this experiment as a viral jam, which is perfect. So we're going to deconstruct this raisin rave and see exactly what makes it so dang catchy and what all of us can learn from its approach.
Okay, first things first, let's look at the method behind the magic. It all comes down to a really simple three-step process that literally anyone can follow. This is the heart of the experiment.
Now, right away, what's so cool is the language they use. The script doesn't just list materials, nope, it gives them roles, like characters in a play. You've got the stage, the fizzy floor, and of course, the dancers. Just by giving them these names, it turns a regular science experiment into a performance. It's instantly more fun and engaging.
And the method itself? It's all framed like a party. I mean, notice the language. Fill the floor, drop the dancers, amp the party. Every single step is active, it's exciting, and it's designed to give you an immediate, visible result. And that, right there, is absolutely key for holding on to anyone's attention, especially a kid's.
Okay, so we know how to make the raisins dance, but why are they dancing? Now let's get into the science of this soda disco. This is where this simple little trick starts to reveal some pretty fundamental principles of physics. So the first concept we have to talk about is density. It's actually pretty straightforward. The raisins are denser, or heavier for their size, than the soda is. And just like a rock in a pond, they sink right to the bottom. That's part one of the puzzle.
But density is only half the story, right? The second key idea is buoyancy. That's the upward push that a liquid has. Now, normally the raisin is way too dense for buoyancy to do anything. But that's where the secret ingredient comes in, those fizzy little bubbles.
And this analogy is just perfect. The script describes the carbon dioxide bubbles as tiny party balloons. How great is that? They get trapped in all the little wrinkles on the raisin's skin, and they act like little flotation devices. It's fantastic. It takes a scientific process and instantly makes it a visual, intuitive idea anyone can grasp.
So here's the crucial transformation. Let's look at it side by side. On the left, you've got your plain old raisin. It's denser than the soda, so it sinks. Simple. But on the right, you have a raisin that's covered in those bubble balloons. Suddenly, that whole package, the raisin plus the bubbles, is actually less dense than the soda. So it floats to the top. And then, when the bubbles pop at the surface, the raisin gets heavy again, sinks, and the whole dance starts all over again.
So now that we get the science, let's really analyze the communication. How does this script take ideas like density and buoyancy and make them totally unforgettable for a young audience? This, my friends, is the masterclass.
The script uses a whole toolkit of tricks. It calls for a super energetic, even giggly voiceover. It uses personification, calling raisins shy guests and bubbles clingy friends. It is packed with sound words like pop, fizz, whoop, and it leans on these great analogies and playful names like raisin rave. Every single choice is designed to max out the engagement and the fun.
I mean, this one line from the script says it all. It's not just an instruction, it's an invitation to feel something, to participate emotionally, giggle along. It frames learning not as some chore you have to do, but as a party. And that approach just completely lowers the barrier to entry and makes these big science concepts feel exciting and totally accessible.
So what's the big takeaway from all this? Because it's really about more than just raisins floating in soda. It's about the incredible power of play when it comes to education. So here it is, the key point. When you make learning hands-on and fun, you transform these abstract ideas like density and buoyancy into something real, something tangible and memorable. You're not just explaining a concept, you're creating a little moment of discovery. And that is what really sparks and sustains true curiosity.
And that really just leaves us with a final thought. The Dancing Raisins experiment is just a perfect example of low-cost, high-impact science communication.
It proves you don't need a fancy lab or expensive equipment to teach profound ideas. So, it makes you wonder, right? What's the next big concept that's just waiting to be explained with a couple of simple items from the pantry?